So I'll share my screen. Uh, so today I'm. So this is the. Can you guys see my screen? Hello. So the page which I'm sharing is the installation for Oxia. This is our one of our client. We're trying to help them create the 3D models. So if you once we log, I'll try to add your user, receive the user list and the email addresses. I'm going to create them. Once we create them, you should be able to access the installation. But let's say once you log into the page, you should be able to see you'll be directed to this page, just like a brief intro, how it looks like. So this is the KPA dashboard. Once you log in, you will see this page. And then once you select this IDMS, browse asset, it will take you to this main page of the software. And so this is where like you see the Oxia site, and you can see the main data sheet for the site. But let's say if we expand the tree towards the left, this we call like navigation tree. So and we are looking for Bay City, and within Bay City we have like these process units. And so now today I'm for the example of the training, I'm just going to work on the heat exchanger HE30. So 100 HE30. So once I select it, you can see here the main data sheet for the heat exchanger. So in order to access the 3D model or the 3D view for this particular heat exchanger, so we select, if you see this to the top, there are different subtabs. So in order to access the 3D model view or like the 3D, to create a 3D model, we'll be selecting the view subtab. So once upon selecting it, so it should take us to the 3D model or the 3D editor. So you can see here, there are two different subtabs within the view tab. So by default, we have this 3D subtab selected. So now in order to create a 3D model, so we say, if we hover over here, it says enable the 3D model. So we can just check this box. And then in order to create the model, so it says edit the model. So we select this box to actually start creating the model within the 3D editing. So here you can see this is the axis. So let's say, for instance, first thing is we'll try to find the orientation, whether it's like vertical or horizontal asset. So let's say we just try to see, this is the heat exchanger that we are looking to create for this training now. So this is the heat exchanger 30, and this is an horizontal heat exchanger, and the asset is horizontal. So we come here, if it's a horizontal asset, we come here and choose the axis as plus y axis, so which is selected by default. But let's say if it's like a vertical asset, then we go by plus z. So and we start creating the asset. So first thing first, we just select the position and orientation, and then we choose, if it's vertical, we choose plus z axis, and if it's like a horizontal, we choose plus y axis. And now, and you can see here, this is the axis, it's pointing towards this side. So upon creating towards the right, you can see here a list of different components for building this asset. So we can, upon selecting each of this component, we should be able to see the component here in a 3D editor. So let's say if we start by, so this is the heat exchanger. So since it's pointing towards right, I'm just going to start from the right head of this heat exchanger. So let's say we go with this head, 2:1 electrical head. So we'll start with that. So head, which is select the head, and you can see it's by default it's showing like an ellipsoidal head. So we choose, it's chosen as default, like for the 2:1 electrical head. Now we can name it as like something like right head, and then we can choose the material. So we can just go to the document here, and we can choose the material for the head. So it's SA51670, or it can also be seen here. It's good. So 567. Okay. we have seen this material. But let's say in a case where you don't find this material from this drop down, so usually you can see here, these are the list of different materials that are populated from either from the standard database or like it's being created over a period of time. So when in a case where you don't find this material in this list, always you can just go to this three dots called the base table. Upon clicking this, it will take us to the material base table where we can actually add a new material. So in case if I want to create some new material, let's say SA105, if I'm missing, so then I can just create this as SA105 and placing the code and description. And here I choose as base material and I save this. So since I already have like SA105, I'm not going to duplicate it. So I'm just saying once we save, it's going to be seen in the list. So let's say we cancel it. So we say, okay, that's it. So here we still have this 51670, and we need to enter the corrosion allowance. Guess it's here, 1 by 8. So I guess somewhere close to 0.15. Thickness, and says 0.5. And we have the diameter, it's 20 inch outside diameter. And you can see here, these are the unit measures. You can also play around different unit measures upon selecting. So we usually keep it as either inches or feet and inches, something like that. So, so the neck, so this is a 2:1 electrical head. So it's going to be like 3 times of the normal thickness. So 0.5, so 3 times 0.5. Sometimes they will provide the state phase, but in this case, we just take it with the standard value. So the neck would be 0.5. The camber, since it's a 2:1 elliptical head, so it's going to be like the height. We need to find the height of the camber. So we call the camber as this is the height. So let's say you increase the height. So this is this height. The height of the head is called the camber. Yeah. So which is going to be 20 inches is the outer diameter, and the inside diameter is going to be, we reduce the 0.5 is the normal thickness, so which will be like 1 inch. So 19 divided by 4 is 4.75 is the height. We set this, and once we have all the information set here, we select confirm. I always come here and say click save. So this way we don't lose any information. So each time I create a component, I come here, click confirm, and come here and click save. So you can see here the model was saved correctly. And then we just proceed with this. We have the shell next. Then we have like this flange. So we will try to find the body flange information. So here it seems we have the body flange information. Okay, so I'll just, to create a body flange, I'll choose the component called flange. But like for usually I use nozzle for the nozzles that are placed on top of the heat exchanger. So body flange, I select the flange. Now you can see it has been created as blind. So we remove that blind. And now we have, I'll just name it as body flange. One. Okay. So now we come here and we will try to find the material. which says rates. So the fittings, nozzles, flanges, go with SA105 unless it states different. Okay. Good. We have, you can notice the correspondence is whatever we set here, it's being populated automatically, but we need to make sure the thickness and the other values are adjusted accordingly. So here we see, okay, 3/60. And we say the diameter of the crown diameter, it's going to be 2 feet, 7/8. Okay, so 7/8, 24. So crown diameter and the crown thickness, we will try to take that value. So this is going to be the crown thickness, 1/8. We go with that. Crown thickness, and we have the neck. So the neck value is here. So 1/4, 1.25. So now we have all the information related to the flange. So we select this and save. Now we go here and we see we created the head, then we created this body flange. Then we see here, this is the tube sheet. So we will try to find the tube sheet information. So here we have this. So I'll just go here within Antea. We have a component called tube plate. So we select the tube plate and we say tube sheet. Oops. 5 on 670. We choose the material for this. Okay, we have the curve allowance, and then we find the thickness. Okay, so it's going to be 3/1/6. Okay, but we still need to find the diameter. Let's see what's that. So still it's going to be the body flange diameter. So it's going to be 24.7875. Okay, so I'm just going to leave it here and then say confirm, and then I'm not creating any the bundle length or the bundle diameter. We just create only the tube sheet. Whatever we see here, not the. So when I create the components or the model, we focus only on the components that are external or pretty much like where we place the CMLs. That's the main idea of creating this 3D model. So right now, pretty much like we are viewing this tube sheet externally, so that's why we just creating this, and then we move towards the shell course for this heat exchange. Say shell course 1. And we try to find the material. Say 106B. Good. And we have this corrosion allowance value. We need to adjust the diameter, so it should be 20 inch. It's the diameter, outside diameter. As you can see here, and you can see it's schedule 20 pipe, or like we have this the thickness 3 by 8. Oops. So we add the thickness here. Then we try to find the length of the shell course 1. So it's going to be 8 feet, 2.25 inches. So one thing is, like you can see here, you can also add uh, within the units. So you can, if you want to add both feet and inches, you can do that by leaving this unit of measure as blank. And then you can say this is 8 feet and 2.25 inches. So it's pretty much straightforward. And once we have this information, we say confirm and save. And then we go to the next component. So this is another shell course, but like this is for the bellows expansion joint. So I'm going to create this as shell course right now. Um, Shell course, I'll mention it as shell course expansion joint. I'll leave it the same. Thickness is going to be the same. You can just copy this value for the thickness. And the length is going to be 1 feet 4 inches. Okay. So we confirm and save. So since this below, we don't have like the bellows in Antea, like a component within the 3D editor. So we are not going to create it. We just create the shell. And they say confirm, and we go to the shell course 3. So each time you make the changes with the name, you can select this checkbox. It will save the information. And we have the material from this previous one. And the diameter, the thickness, we try to copy this from the previous information. And the length of the shell course 3 is 10 feet. Okay. I can say, you can also add the symbols. So let's say 10 feet. It's going to take 10 feet. Let's say cut and save. Now we can add the left tube sheet information. So just going to go for the tube plate, left tube plate, tube sheet. And we already saw the tube sheet material is 51670 here. We have the corrosion tolerance, diameter, we need to change that. So it's going to be, you notice here, we need 2 of this, so which means one is on the right and the other one is on the left. So we take it as, take this diameter, 24.875, I believe. Let's see with the history. Yes. With the diameter, the thickness, 31 by 60. And we confirm and save. Now we go towards the body flash for this channel. So let's see. So this is the similar one. So we're going to create the body flash for the channel. So we select the flash and we say channel body flash. And then it's going to be 105. See. So again, it's 24.875 is the outside diameter of the crown. It's a crown diameter, and we have to adjust the thickness. Let's see what it is. 16. So this is the thickness for the flange, but we also have the thickness for the crown. So we add that. So it's 3/1/8. Okay, so we have pretty much all the information. So one thing is like it's blinded, so we need to check this box out. It's not blinded. Okay, so we have everything, but we have to add the neck value. So 1.25. And you can see here, this flange is actually kind of inverted. So we have to manually invert this by selecting the invert. So now it's been inverted. And we say confirm and save. Now we are going to create this shell course for the channel. So for the channel, we just go here and select shell as a component, and we say here as channel course, and save this information. And probably it's going to be the same material for the shell, SA106B. And we have this thickness. So we go that same value, 3/8. And we have the length, one feet. So I'll just go here. So 1 feet, inch, perfect. Confirm, save. And you can see here, if upon selecting this component tree of component within this tree here, you can see the list of different components that are actually created. And if you were to go back to the sum of, let's say if I want to go to the head, I can just choose the head from this component tree. So I can say, now you can see here, the data sheet for the head has been selected. And if you want to modify any information, you can actually modify that. And then you can come back here. Let's say if you want to come to this channel here, you can just select this by upon selecting within the 3D editor, or you can also select within the tree. So we save this. We're just going to hide this tree. Then we need to create the head for this, the channel, and it's pretty similar for this right head. So I'm just going to create the head for channel. So I'll say left head. Okay, so and then the material is 51670. And the corrosion allowance, that's good. And the thickness is 0.5. The diameter is 20. Now we go with the straight face, the neck value. So for the 2:1 electrical head, we just go with the value 1.5, straight face standard. And then for the height, it's going to be 4.75. See, it's 19 divided 4, it's 4.75. Save. And in some cases where actually like I try to have a case where it's not an elliptical head, I try to use some formula which I have here. Probably I'll add this Excel sheet too. maybe you can add it for a reference and try to use them to find the head height. Maybe something if you need it, you can use them. I'll upload it in the shared drive. Mm, so pretty much like we have created the head. So now we created the components, pretty much like the main core components, head, chambers, shell courses, channels, and the heads. Now we will try to see what are the other things we have to create other than this. So as I said, bellows, we don't have a bellows within the Antea like a component. So we just create this as shell course. Um, and we see here we have the information about the nozzles. So this is the plan view of the drawing. So we have some towards the bottom we have the bill of materials where we can find the number of nozzles that needs to be created. So there are 4 nozzles that needs to be created. So let's see, we start with the one here towards the right, the T2. So let's say if we want to place a nozzle on the head, so I select the head either by selecting on the model, or you can actually come here and say right head. It's going to select by default. And to place that nozzle on top of the head, let's say this is on the top end, so I just going to select top end. So you can see here this axis will automatically pop up this arrow pointing outwards. So now we are going to create this flange or the nozzle. So first, how we create the nozzle is like we create the neck of the nozzle and then we go for the flange. So let's say for T2, I'm just going to create the neck, and the information for the neck can be found here. I guess it's for T2, it's 3 inch, 0.438 is the thickness. Okay, so the projection, we need to check the elevation. Okay, so we'll see pipe for the nozzle neck, and then I say T2 neck. I save this information and I'll see what's the material for the neck. Here it says nozzle flanges, nozzle neck is 106B. Okay, we go here, 06B, and the corrosion allowance value is pretty much good. So it says all throughout this will have corrosion allowance, so I'm going to take it. T2 thickness is 0.438. So the thickness and the length, we will try to find it. Here should be, says 1 feet. It's 8.5 by 16. So let's do a math here. So 8.5 by 16 plus 8 and 1 feet plus 12. So this is the total distance or the total height. So I'm just going to subtract each of these values. So we know the value of the neck value of the head is 1.5. So oops, I'm just going to subtract those values from this. Minus 1.5 minus 4.75 is the distance or the height of the head that we calculated. So 14, and then we need to subtract the crown thickness. So that is actually 3/1/8. So I copy this information. 3/1/8. Sorry. Okay, so we reduce that value from this, and we have this is the height, but we still need to. We'll see if we're missing anything else. So this is good. We separate it. Okay. So this is the total height of this neck. Let's say actually this 10. Now we set this pipe size and then 3 inch. Okay. So we say here 3 MPS. and we say confirm. And now we are going to create the flange. So usually when I create the body flange, I choose this flange component. But let's say when I create the nozzles, I choose nozzle. You see there is a component called nozzle. So now we do the same. We come here, we try to add the name of the T2. So the T2 is actually channel outlet. So I say that here, channel outlet T2. And we know we will try to find the material. So it should be here, say 105. And select the standard from here. So let's say, for example, so this is 3-inch 600 race face bell neck. So whenever we want to select a standard, so the dimension will be populated by selecting the standard. So let's say we select for this flange, we have this option for selecting a standard. So we select this button, which will take us to this table or the base table. So here you can see this is the bell neck that we are looking for, but we also have the different kinds of flange, or like the different types of nozzles where we can choose the standards from. So here we, by default, it's showing 3-inch. What are the different classes of the flanges are available to choose? I think we want to choose 3-inch 600 well neck. So this is well neck 3-inch, and choose 600 and select OK. And this should take care of the dimensions for the nozzles. And we select confirm and say save. So that's good for T2. Now we go to, we'll keep creating the rest of the nozzles. So I see, so these are the orientation. So let's say now to find the angle or the orientation, there should be a reference point on the 3D editor. So let's say if you are looking for where's the reference point or the 0, so this green line you see here, this is the reference point. So in a case where if you don't see this line, I will always come here to the bottom, and where you can see these 3 dots, 3 lines or 3 dots. You can select that, and you see there is an option for show meridians, and you can check this. Upon checking this, you should be able to see the reference line. So this is what we call as the 0 angle, or this as the reference line we say as 0 here. So at 0 we have S2. So this is the branch that we are going to create. So let's select. So it's going to be on the shell course 2 or 3. So we select outer wall. So this nozzle is going to be created on the outer wall. So as I said, we are not creating any internal components, so it's going to be on outer wall. So we select outer wall and say neck, or the pipe. That's the neck for S2. Select, save this information, and SA106B, that's for the neck. And now we find the thickness and the diameter. So it's 6-inch 0.432. Okay, 6-inch 0.432 is the thickness, 6 inches the diameter. Okay, and then we find the height. So here it says the projection is 20.625, which is actually from this center line. So which is 20 by half is 10. So 20.625 minus 10 is going to be 10.625 is the length of this pipe or the neck. Now we have all the information, but now you can see here this nozzle is actually placed on the 0, because when we created the shell course, it has been created from the left to the right. From the right to the left. So that's why you see the nozzle is actually at the position 0 on shell course 2. But let's say we have to actually move the nozzle towards the left. So how we are going to do it? So I'll show you. So here it is actually 1 feet. Let's see how far it is. Let's see if we have some other information. No. Okay, so here it says 1 feet. This is the work line. So it's 1 feet, 1.5 by 8. That's the distance. So I'm just going to convert that into inches. 5 by 8, 1 inch plus 12. So this is in inches, and we try to subtract this thickness or the tube sheet value. So 31 by 16. So I'll just copy this value. 1 by 16 is 3. Okay. So this is actually the distance. But you can see here it's 120. So we have to subtract to actually do the right distance. So it's going to be 120 minus 10, 1.5. So this is the actual distance. So if we place this value here and we select here somewhere, and we can see this is the proper distance where we place the nozzle. So this is the distance is where you can navigate between left or right, and the angle is something we try to play around. Now I'll show you. So since this is at S2 is at 0, so we are not going to change anything, but I'll show you soon how we are going to create for different angles. So let's say, for example, if I try to make it as 90, it's going to place 90, but make sure it's actually matching the drawing. So sometimes it says 90, but like it's not actually 90, because in this the axis is, if you see here, it's actually plus 90. So we need to try to match the plan view of the drawing to see if the nozzles are placed properly. So let's say we keep it as 0. So this is good, and we select the nozzle and say S2 shell outlet. It's SA105. We have that correction allowance. So now all this dimension, we will choose the standard. Select the standard. We'll make sure to choose the right one. So it's 6-inch 150 RFWN. So now you see it's coming. This information is coming from the previous flange that we selected. So we remove this information. Remove the class, and then we need 150, so we choose this 6-inch 150 and say okay. Now we have created the S2, and then I will come here and try to see. Now we have taken care of T2, which is at the center, and the S2, but now we are still left with T1 and S1, which is on the 180. So here T1 and S1. So the T1 is actually on the channel. So we'll go with the T1. Set 5 on the outer wall, and we say T1. Neck. Let's say 106B. Let's see what is the height. So it's 20.625. As we calculated previously, it's going to be 10.625. Okay, we try to use that information. Okay, that's the length of the projection, and we try to add the thickness. So it says T1 is 0.438. inches. So we have the allowance, material, length, and the diameter. So we'll try to see what's the diameter. It's 3-inch. NPS, so we just select the NPS and we say 3-inch. Next we will try to go and find the distance. So I say that, so the angle is actually here is 180, as we spoke. It's 180. So 180 is straightforward. We can just say 180. It will take care of it. and the distance, we'll try to see where it is located. Okay, so here they didn't mention it. I guess it's here. Yeah, 7 by 16. Okay, we'll do the same. 7 by 16. Then, but we have to subtract the thickness of the body flange, or the not only the thickness, like the total distance. So it's 4 3 by 8. Okay, we'll do that. Oh, we subtract the value and we'll get this distance. Confirm. You can see here it's been placed, and now we place the nozzle. So let's see what's the name of T1. It's channel inlet. Okay. We say the material as SA105, and the corrosion length is still good. So now we try to find the flange. 3" 600 well neck. Good. So we need to adjust this. 3" 600 well neck. It's good. And confirm and save. So now we created the T1, and we have left this S1. So once we finish S1, then she should be good, I guess. So let's see. S1 is actually placed here on the shell course 1. So outer wall, we select the shell course that we want to place the nozzle on, and then select outer wall and say select the pipe. S1 neck, and this material is good. SA106B, corrosion tolerance. We'll try to find the thickness. S1 is 0.432. And I guess it's 6". Now we'll determine the height of the projection. So S1 is 18.9375. So which means it's going to be 8.375, I believe. It's 8.9375. And we have all these information populated. Now we set the angle, which is 180, and the distance, let's find it from the drawing. Okay, so it says 19 feet, 1 3 by 8. So which means this is the work line, and it's 19 feet away from this way. So which you have to calculate that. Let's say 3 by 8 plus 1, so 19. So I'm just going to convert this into inches. So this is the total distance, but we have to subtract these total distance, like 10 feet. So 11 feet 4 inch. So 11 feet 4 inch. Okay, so let's see. 1, 126. So this is the distance we want to actually add, but but we have to do the reverse. 98. Okay, so we have to subtract this value. 8 minus. So this is the distance we are looking for. And we confirm. I said it's nozzle. S1, it's going to be shell inlet. 105 material, and the standard is going to be 6-inch 150 or well neck. So well neck 6-inch 150. Okay, confirm and save. So this is good. So I usually once I make sure all the components are here. So let's say there are 4 nozzles. You can see here we have all the 4 nozzles, and this is the plan view, which I was saying. Uh, Maybe this 0 is here. So at 0 we have S2, and T2 is over here at the center. We have S1, T1 and S1 at the bottom, or the 180 at 180. So this is what we saw here. So we have pretty much completed, or we have completed all the components, and the model is good. We save, and then we check this box out. And I usually have like a copy of this file. Once, let's say if something bad happens, we can have like a backup. So I usually download this model. Once I finish creating everything, I say click here to download as this file. So whenever you have some issues, you can always come here. Either you can replace the model with the file you already have, or somebody changed it by mistake, or something happened like a bug or something. In that case, we can just come back here and try to, let's say, upload this as a total new model. So it's better to have like a download or a backup of this file. I usually download both these two formats. So one is IFC and the other one is EY EYWA data file. So yeah, so that's pretty much about like the how we create the heat exchanger within the 3D editor. Any queries so far? I know it's very quick. I was telling very fast. Please let me know if you have any queries or concern.
Uh, is there a way to add the reinforcement pads?
You can add it, but like for this project we didn't add any reinforcement, but like you can add it. So let's say for instance, if you want to add the reinforcement, right? Let's say I'll just going to add this. I say out wall, right? So reinforcement, I usually choose circular plate, and let's say we say repad. For this is for, I guess it's T1. Okay, repad. Okay, so here. Okay, where is it? Ah, okay. So let's say we will try to create it. I'm showing but for this project we are not creating the repads, but I'm saying how to create. I'm just showing how to create it. Say 51670, 670, and then we try to find the diameters of the repad. It's there. Here, I guess they are providing this information about the repad here. So we are looking for T1, I guess 7.5. 1.5, and I guess the internal diameter is going to be 3 point something, I guess. Let's see. 3.625, and the thickness 3/8. And so finally we will try to add the distance. Finish. Sorry. So here. and we say 180. And you should be able to see the repad here. Sounds good?
Okay, good.
But like for this project, like we are not creating the repads, so we're just creating only the nozzle necks and then nozzle
The courses
the courses nozzles. Yeah, not like too much into like
detail.
too fine details. Yeah.
Okay,
So pretty much like whatever we see outer components, so shell courses, heads, body flanges, tube sheets, nozzle necks, nozzles, in some cases, yeah, like mostly those are the ones. But like if there is something strange, please let me know. We can take a call from there. But repads, I'm not creating any repads so far for this
right.
project. Yes,
Okay.
good. That's a good question. Okay. So this for the heat exchanger. Do you guys have any other queries or like do you have any issues finding some standards or anything or have you accessed the installation, something like that? Please feel free to ask me. Uh, but yeah, maybe once you start using it, maybe you will find some queries. But like I'm always there. Please reach me out. So this is for heat exchanger. Do you want me to show one for vessels?
Yes, please.
Yeah, perfect. Sounds good. Maybe I'll take a look on this. So I'll close these guys. Okay. So I will send you those documents within the shared folder soon. I just received today. I'll try to share those information. So let's see. I'll have some example pretty much set up. Let's see. 1, 3, 2, 7. Okay. All right. Let's see. This is okay. Let's take a look. The most important thing is like whenever you open the document, please make sure the asset number is right. Sometimes the folders might be misplaced, so it's please have a look before even start creating the 3D model. Please check the asset name. So
Okay, check.
yeah, just the tag. Yeah, before
Okay.
so to make sure that's the right drawing. Sometimes it's what we got from client, maybe that might be misplaced. Mostly it's properly placed, but in some cases it's better to check it.
Yeah,
So yeah,
great.
we're so yeah, if no queries with the heat exchanger, I'll just go on do this example for the vessel. So this way we cover both vessels and heat exchanger. Okay, so let's try to find the asset within the installation. So here, if you see here in the installation, it's not stating as HE30 or so pretty much you will see somewhere, if you select you can see here, this is the P-units, right? So when you see the list which I'm going to share to you, it's going to be like something like this, which I'll show you soon. So it should be something like process unit number here, and then you have all the assets. But like if you try to find this number in the installation, it won't be like straight away. It will be like something like with the process unit number, like a prefix. So let's say it's for this instance, HE0723. If you're looking at 100, process unit 100, within the installation, it's going to be like HE, let's say 723, right? So here, it's going to be HE0723. So just like a FYI, because this 100 is actually the process unit, and HE is
Oh,
like
the prefix is that 100 prefix is for the process.
yeah, that's for the process unit. Yeah, that's the prefix. Yeah.
Okay.
So, but on the list it says as HE0723. Just so usually when you try to locate, you see this is the process unit, and then 100 HE0723 is actually the asset. Does it make sense?
Yes, yes.
Because
Clear.
initially we had the tag, this is what the original tag was, but then we have modified it so the customer asked for like a more easy way to track, because there are some assets with similar tags in different process unit. So we just say, okay, we try to have something unique for each process unit. So this way it's easy to classify. So
Right.
perfect. So I'll just start with like one example. Okay. So we are looking for 1327, and usually I what I do is like there's a good way you can like a quick hack. I'll see whatever the asset. Let's say I'm looking for a vessel. Usually these are the type asset categories: heat exchanger, vessels. But there are some you will find it here as well, which is not in the categorized state, because these are coming from P&IDs. So just like, so if you want to find some asset, right? Let's say for example like a vessel, what I do is so I just select some random asset and try to copy this with the proper process unit and come here and select this magnifying symbol. It's like a search toolbar. We paste it. I put the percentage symbol on both sides. And then let's say we are looking for 1327. So 1327. Let's see. So it's been located. We select this. It's easy to navigate. So now we found the asset. So it should be, if you see in the tree, so here, see. And now as we were to, because this is on the main sheet, main data sheet that we are seeing for the 1327. So now to create the 3D model, so we'll have to choose the view subtype, and then we choose, since this is already been selected, the 3D model, we choose edit the model. So technically that will help us show the axis or like the pointer where we start creating the components. This is the 3D editor. So so we'll check what is the, so this is the proper asset tag, and then we'll see what is the orientation. It looks like this is horizontal as well. So we are going to keep it as, we select this position and orientation, and we make sure this is plus y axis. As I said, if it's vertical, please go for mouse to z axis. So we skip, since it's horizontal, I'm just going to keep it as positive y axis. And then we are going to create the components from here. So let's say I'll just do the same. I'll start from the right. So we'll start with the head here. Okay. It looks like, say, in some cases, what happens is the previous instance, we actually didn't have the information. I'll just try to show you one more quick example. So in the previous instance, which I was showing for heat exchanger, the 30, when we created, we just keep creating, like, let's say, if I want to create like a nozzle here, I'll just say top end and I select pipe. It just creates a pipe. But because this is like a total fresh asset, or like this asset doesn't have any components created, right? But we also created some components without the 3D model. So for instance, what we created here in HE30, right? We did all created the components in the 3D editor. And if you go to the components tab, you will see there is a tree here. If you select the, for the 30, if you expand the tree, you can see all the components here will have the data sheet of each of the components. And you can see here, all these components are populated or created within the 3D model. So which means these are actually created in 3D model. These are not created by manually within the components tree. But the one which we are looking at is actually a bit different. So let's say 237, 1327. Okay, 1327. So let's see, this is the 1327. Okay. Okay, so here, if you see this component sub tree, right? So we still don't have the 3D model created yet. So let's say if you edit, it's still blank, but you'll notice that here, the components are actually being created. these components are actually coming from the U1 sheet. So in this case, what we do is like we try to use some of the information that is already here, but it's not complete information. There are some partial information that's coming from U1. So what I do is like I try to use it if it's if I feel like worth it, or if you feel like it's not worth it, you can just create as a new component. Don't worry about it. So I click this as edit the model, and as I said, we check the orientation, horizontal, positive Y, that's good. And let's say if I select head, I believe like here there is, it's showing as two different heads. So I'm just going to choose one. Let's say confirm. It's not good. So what I do is like I've come back here. So we will do as what I shown you like in the previous case. So we don't want to use this components. So I'll just choose head. Instead of choosing from this list, I'll just choose new component. So, and you see this new component has been created, and now we say right head, and now we populate the material. We'll try to see if we have the materials for the head. Here we have 516070. That's good. Corrosions. Let's see if we have on the 8. Yeah. It's good. Oops. On the 8. Then we need to check the thickness. So it's over here. 5 by 60. We choose the diameter 42. And it says neck is 2-inch straight face, 2-inch. And this is actually not a 2:1 head picker head. It's like F&D head. So I'm just going to use like the Excel sheet to with this formula. We'll try to find the head. So we'll see the crown radius is 36. Okay, 36. And sorry, the knuckle radius is 36. The crown radius. Two, 3 by 4. Okay, so here 2.75. 2.75 is the knuckle radius and 36 is the crown radius. Inside diameter, so we'll try to find that. So 2 times of this normal thickness, and we subtract that from the outside diameter. 42. Oops. So this is our height of the head, 8-inch. So we go with the camber is where we set the height. If you get confused, this is the place where we set the height of the head. Camber is the place we set it, and we have all the information. We say confirm and save. Now it asks like, okay, I'm just going to say some of the components. Yes, I would like to delete. So just delete. It's good. Because what we're doing is like we're trying to keep it as all the information. Now we are going to create it from the drawing, not from the UI. So we keep it as because the components are based on the reference from the drawing. So we use this information. So that's good. So now we will go back to the drawing. So we created the head. Now we'll go to the shell course for the vessel. So it seems 8 feet is the distance. I think 72 inches. Okay. Let's see. It's 80, 72. It's not 80. It's 6 feet. That's that. Okay. So we choose the shell course. It's not already being used. I don't know why. Okay, now I see what's happening. Okay, I'll try to get out of here. So now you see something because there was previously some components with that name which we deleted. Now that's why it's showing it. So it's not letting us create with the same name. I usually, if it happens, I'll just disable this editor, and then I come back and see if I can add this name. Okay, shell. It goes good. So we'll try to find the material. Same 51670. I think it's good. Corrosion is good. Diameter good. Thickness 3 by 8. And we got the length. I'll just use inches. You can also go with the feet. It's up to us or up to you. Confirm, save, and we have the head shell course, and again we have head. It's going to be the similar one that we saw here. So we go with this head. I will say left head. Save. 51670 is the material. Correspondence is good. And we have the thickness 5 by 16, I think. Yeah, 5 by 16. Good. 42 is the outer diameter. Neck is 2 inch. It's the straight face that we have here. And with this value and from the height, we found that it's 8 inch. We'll go with that. Good. So now we created the shell course and the heads. Now pretty much we have the code. Now we'll focus on creating the nozzles. So we have this end view or the plan view. So this is where we are looking at it is. So 0 has FECD, 180, and there are these nozzles. I'll start from the nozzles on the head. So L4, L2. Okay, we'll start with that. So this is actually at the near side. Okay. So usually when I create the top end, you will notice here, if I place a pipe, let's say for instance, 10 inch, just for instance, I'm showing. So here it's on the top, right? But you can't move. There is no option to set the distance or angle. So in that case, we don't use the top end as connection. So what I mean is, let's say if you want, we have to place the nozzle on top of the head. For instance, this L4, if I want to place that, it's a 6 inch away, or like there is some angle involved in it. So what I do is like I'll select the head and I'll choose, instead of top end, I choose outer cam. So now I choose the pipe and let's say confirm new component. And now we are looking to create L4. So I say L4 neck, and we try to find the material for neck. Okay. 106B. We have the corrosion lens thickness. Let's find it. So it's L4 schedule 160 3 by 4. So we saw like how to select the flange class and from the standard, or flange type and its class from the standard. We can also choose the schedule from the standard. If you see here for the pipe, select the standard, and this is for 160. So we can choose 160 and 3. So you can choose this. You can choose the schedules where you see pipe and also for elbows. So choose 3/4, 160. Now, usually the values will be pretty much populated from there. All the dimension for the pipe will be taken care. Now we focus only on the distance and the angle. So let's go for it. And the projection. So the projection, it says typically 10 inches. I'll choose, I choose 10 as projection. Okay. And now we will try to find the distance of this nozzle. It says 18 inch from the center. So it's like, so you can just choose the inches and 18 inch. That's good. But you will see here, this is actually at the center at 0. But we are looking for something which is not an angle, it's in inches, which we don't have it in Antea. So what I usually do, I just go like this way. Okay, it says 6 inch from towards 0 to 170, 270. So if you see here, this is the reference point, and the nozzle should be somewhere here. So I'll just go. I'll just try to see which direction it is. It's either positive or -6. So I'll say +6 angle, or like I'll just try to see. Okay, I see it's somewhere here. Okay, so what I do is like, since we don't have values as, we can't make the distance, we can only set the distance from the center to the corner. We have only the option to move us from the center to the, it moves only from the, it moves like a radial direction, or like in a radius. What I mean is, let's say, for instance, you can move the nozzle only like, let's say if it's 0, it goes to the center, and if you all the way move it, so it goes only this direction. But like to, for the angle to move, we have only the angle but not the distance, right? So in this case we have the limitation. So what I'm doing is, I'll set the distance which we have already, 18 inches, what we have here. So this is the distance, it says here. But this 6 inch, I am going to use that as 6 degree, which is not true, but like because we don't have any other option, it's just for a random value. But what I do whenever I do this, I'll come here. Let's say, for instance, you should be able to see a Excel sheet where it has that, let's say this for V1327. I have like a section for components or notes, right? So I mentioned here, let's say, all the nozzles placed on the head, all the distance of the nozzle, sorry. Yeah. So this way we know, okay, this is an assumption. And as I see here, once we complete the model, I usually come here and set it as complete. If there is some issue, I usually just leave a note here, it's not completed or something issue. Always we set the comments on the sheet, which I share the Excel sheet with you. You can leave the comments on the notes. Also, I'll add any assumptions that has been made. I'll try to add that as well. So here, the distance is not actually like the actual distance 6 inch. It's just because we don't have the, there's a limitation in Antea where we can only set in angles. So we have this information and confirm, and then we place the nozzle. We're looking for L4, right? L4 level, it says level L4, and we'll try to see the material available, nozzles, not next. Okay, well, fittings. I think it's fittings. Yes, I'm understanding right. It's SJ234 WPB. Okay, WPB. So I'll just type WBB. It should show, okay, say 234. I'll just choose this. Okay, so no material is done, correspondence is there. Now we choose the proper branch class. It's 3x4, 150 well neck. 3x4, 150 well neck. Okay, 3x4. So that's good. Confirm. So L4 is created. Save. So now we create the other neck, other nozzle. So here we have L2. Okay. And this is going to be, I think it's 106B if I'm right. Okay. And we have the correspondence. We try to find the thickness. Say it's 160, 3x4. Okay, we do that from the standard. 160 has been selected, 3x4. Choose them. Okay. Now we set the projection. We already have the projection, which is 10 inch. And then now we set the distance. It's also 18, as we saw here. And the angle here, now it's going to be 6, but like -6. It's in the opposite direction. And we say L2 well WPB 3. Choose the standard. It's good. And I'll see if it's actually hitting together. So I'll just move, because all these are random values. So I'm just going to move approximately some value, give like 10, so that it gives some distance. So these are not actually exact. Oops, sorry.
-10.
-10, yeah, if you are right, 1 point. That's good. Perfect. So we have these two. Okay. Then we have L1 and L3. Camber, pretty much repeating, but I'm just L. One is 6B, and because we have 4 nozzles, L1 to all the way to L4. You see here, pretty much the same dimensions and same flange type. So I'm just going to, that's why I'm just not looking at it, just use those values. And so we have projections, values, and the distance, I think it's the same, 18, yeah. 18. But now it's going to be the opposite. So we'll go somewhere close to 180 to 170. Let's say these are random, but so this is L1. So make sure it's in the, it's making the views pretty much similar. Yeah, so here 170, and we say 11. Oops. Okay, that's good. Okay. All right. So remember one more for, I think it's for L3. Yes. So 6B, we have this 3x4. 10" 18, and I say minus 170. Okay. All right, so we covered all 4 nozzles that's on the head, and we have T1. Let's see what T1 is. So T1 is it doesn't have any information, or I believe it's like a thermowire, I guess. We don't have a component for thermowire, so we're not going to create that. So T1 is, we don't need to create unless it's like a nozzle or like a flange. We usually create them. So this if it's a thermowire, we don't have like a component, and also it doesn't have any information related to thickness or pipe or anything. We ignored that. So we have created all the components on the head, all the nozzles on the head. Now we'll try to focus on all the nozzles on the uh, shell courses. So we start with the angle 0, FECD. Let's see. Let's start with F. So we select the shell course and say out1, straightforward. Say F next. So this is 106B. Now we'll have the consonants, and then the thickness we have to find it from the table here. It says 1 inch, 160. So usually the thickness should actually automatically comes from this schedule. So that's good. And then oops, didn't select that. Okay, so now we have to find the projection. Says 29. Let's say this is actually from the center line. Let's say 42, 21. I guess we make it as 21. So it's 8. Inch, and we try to find the distance. The angle is good. It's 12 inch and plus 6 inch. Okay, so it's going to be 18. We set the flange on the nozzles. So the F is going to be, we find the name, it's recirculation for F. And WPP. Okay, we'll see what type it is. Wellneck 150. Okay. Wellneck 150, 1 inch. Good. Confirm. Save. It's good. Then we have E and M1. So I guess if you see here, it's E is the one that's at 0. M1 is actually at 90. So we focus on E first. Oops. Yeah, the allowance. Let's try to find the thickness and the size. 3 inch excess. 3 inch excess. Let's go with this. Okay, so 3 inch excess. Projection. Okay, projection. It says 29. Okay, still the same. 8 inch. Right, let's find the angle is good, 0. The distance, 2 feet 6 inch, straightforward. Okay. Okay, and I see this is actually 2 feet 6 inch, but we have to add this. This is actually the distance from the walk line, so which means we have to add the 6 inch, which is 3 feet. So here I'll just say 3 feet and confirm and nozzle. So E 3 inch 150 billet. Okay, and that's a relief. Yeah. Well, like 3 inch 150, good. That's good. So save. Now we go to the M1. Okay. Since it's already here, I'll just okay. But let's see. We will finish all the ones at 0. So this way, but it's up to us. We can always, since it's we already have the distance, so I'll just go with the M1. So we go here, choose of 1, 5, M1. So let's see what's that going here. M1 says with this, yeah. Materials 106. Says 16 inch. Oh, sorry, 20 inch. Extra strong. Okay. Oops. Inch. Okay, now we try to find the projection. 31. Okay, so which is 3 more, right? 30, 31. Okay, it's 10. All right, so it's going to be the angle is actually 90, but you see it's actually going the other way. But because we see the plan view or the side view, it actually should be towards the right. So what we do, we try to make it as minus 90 and 3. So always please feel free to check the plan view and place the angles accordingly so that it matches the orientation of the nozzles. And we have all this distance and angles created, confirm. And the nozzles. So M1, I believe it's a manway. Yes, manway. It's good. It's good. Angle J. Manway 20 inch 150. It's good. And confirm. And this one has a blind flange. If you see here, it says blind flange with the blind. So we can always come here and say flange and then say blind flange. And one, then we choose standard. We have blind flange like a type. So we choose blind flange within the standard, and we have already 20 inch 150. Choose this, and you can see here the blind flange has been created, and but we invert this, and you can see it's properly actually created as blind. So it's good. We save. So we are not going to create this man, what we say, like the David. So we just create only the manway itself. Now we have E1, F, M1. That's good. C and D still on the top. I'll come back and create the A and B later. So we focus on the C and D. Oops. The first one is C. Then 6B. Let's see the dimensions. C has 1.5 extra strong. Let's see the projection. Okay, C is 29, okay, which is 28. All right, we'll set this angle as 0 inches or feet. Let's see. It's 3.6, which is 4 feet. That's good. And we'll place the nozzle. C length. Let's use what type it is, 150, well length, 1.5. Okay, it's the one well length, 1.5. Confirm, save. Of 1. And I think it's F. Oh, sorry, we already have F. It's D. Six B. It's good. Let's go with the standard schedule. D. It's 3x4, 160. So we change from XS to 160. 3x4. Okay, it's good. The projection is 29. That's 8. So let's keep it as 0, and I guess it's going to be 5 feet, 4 feet 6. We make it as 5 by adding 6 inch. So this is good. Okay, so we have D, just pressure. So D is 3x4, 158 W. Right, it's good. So we create D. So we have pretty much cover 0, 190. Now we have to cover the rest. We have 0, all these and the heads, 0, 90, and the rest is on the bottom, 180. A and B needs to be added. So we have A. Let's start with A. Okay, let's see what the values are. Okay, so A 2-inch extra strong. So good. Now let's see the projection. Okay. Oops. Let's see. This the angle is 180, and let's see the distance. It will be 6-inch. So still in the bottom, we take the nozzle. So nozzle is inlet to 150 inlet. Inlet well neck 2-inch 150. Okay. So confirm and save. Oops, my bad. I missed the elbow.
Yeah, the elbow, right?
I missed the elbow. That's a good catch. So we add the elbow. Okay, confirm. Elbow. I'm just going to say elbow. Let's see if we provide the materials for elbow. I'm just going to use the same. Let's see if it's here. Okay, so it looks like it's not. Let's see if it's somewhere else. Okay, so this is the only drawing I have, but it looks like a 90-degree. So what I do is like I'll use the same like this, like WPB, and I go with the standard. Here, if you select the standard, it says long radius elbow or the short radius elbow. I go for long radius elbow, and it's 90-degree for 2-inch axis. Okay. But like only thing we need to see here is the orientation is towards the right head. We will adjust that. I'll show you real quick. I'll add the nozzle we already created. Since we already created and deleted, you can see here I just chose from the drop down and I say confirm. But one thing we have to adjust is we need to see which direction the nozzle needs to be faced. It seems it should be somewhere close to the other side of 90 degrees. Yes. Okay. So which means
270.
yeah. So we say that 90, it's going the other way. Okay. You see, there's a field for torsion. Torsion will make you like try to rotate the elbow. So that's how we, yeah. If you're looking to rotate it, we can use that torsion. Perfect. So confirm. I think we have all this good. Okay. Save. Five. I think it's B. It's 2-inch axis 29. Okay. Okay, this is 8 inches, and the angle is 180. Let's see if it's because it's going to be in feet, I guess. Okay, okay, 5 feet, 6 inch. So we add the 6 inch. Right, and the elbow is here. It's 92. Okay. Fix the flange or the muscles. B. Okay, so B is outlet to 150. Well, like to 150. Yes, it's oh my god. Okay, keep me thinking. I have it. Yes, I already added the elbow. Okay, that's good. And if you see here, if I come here and try to add the outlet with the same name, it won't let me because I just created, but like, so what I do, I'll come here, I say, I'll come back and disable the edit the model view, and I'll jump back again and try to update that information, and probably remove the orientation of the elbow. Outlets, B, and standard has been not chosen. Okay, so we choose the standard. Good, and the final thing is the oh, so make sure it's pretty good. Yeah, pretty much it's a tilted view, but yeah, so pretty much we have all the nozzles created. The components are good. We save this guy. And as I said, I usually have a direct. I will once I create it, I'll just download this files. I'll create a folder within the share drive. You can place them uh, once it's done. You can just place it within the share drive. All these files.
Yeah, for a backup file.
Yeah, like a backup. Yeah, in case something happens, we can use that, so we won't lose any data. So
okay.
So anything, I guess it's much simpler than the heat exchanger, I would say. So this is how we create the vessel. So do you have any queries, or do you find something strange behavior, or like you found any queries here in this particular aspect?
And not so far.
So far, okay.
So far, so good.
So far, so good. And one more thing which I didn't cover yet is the tanks. Tanks is I still didn't find some example. Once I find, I'll show you how to use this tanks, because tanks is something usually we have shell courses, right? But for tanks we have tank shell as a component, right? So usually, let's say it's on the tanks is usually we set the diameter for shell courses and the thickness, right? But here we add the offset and also the width of the, what do you say, the length of the each of the shell courses. And we also have tank roofs, right? Some cases we have floating roof or fixed roof. In that case, we use that. But for now, I'm just leave that for a different day. I'll find a good example for tank and I'll show you. But so far, if you find any tanks, please mark it down. I'll come back and try to do one more session of showing you how to create tanks as well.
Okay.
Yeah. Perfect. Sounds good. Yeah, so this session has been recorded. In case somebody wants to rewatch it or any queries, please feel free to reach me out. We can always set up a meeting and see, because I was trying to show very quick, but like once you start using the installation, maybe if you will find some doubts or some glitches, please feel free to reach me out. We will see, we'll try to sit and figure out what's happening.
Okay. Okay.
Perfect. Perfect. Thank you.
Thank you.
Thank you. Have a great day, and yeah, talk to you later.
You too.